Next is what is this wave number? We will see wave number. What is wave number in a wave, right? So here I am taking a wave. This is y of t and this is time axis t, right? So here I am taking a wave like this. Okay, right? So for this one, first I will write which one phase difference, right? So to write down the phase difference already in the previous video already explained, but here again I am writing the basic formula here, right? So what is that formula? So already you know this is lambda or this is t. So already explained in the previous videos. Lambda is wavelength, t is the time period. So this lambda and which one time period is for one complete cycle of a wave. What is one complete cycle of a wave? If the wave contains one first and one trough and starting and ending points are at mean position. This is a mean position. Why? Because particles are at rest position on this line. Particles will not vibrate. Whereas on the wave, particles will vibrate like this. So that's why you are getting a wave. Because vibrating, you are getting a wave. So on the wave, particles will vibrate. Right? So perpendicular to the direction of the propagation, hence it is known as transfer wave. So already defined in the previous videos, this one. Right? Now, so this complete cycle means it should contain one thrust. Thrust means maximum point on the wave on the upward of mean position. So this is a maximum. This is the maximum in the downward. So this A and B are known as maximum points here. A is known as thrust here, B is known as trough here. So if the wave contains one thrust and one trough, starting and ending points are on the mean position line, then we can say it is a complete cycle of a wave. One wave we can say. Right? So this one wave is known as wavelength lambda. This is known as wavelength lambda. So lambda definitions are, many definitions are there. You can see that previous videos to define the wavelength lambda. But here this is sufficient for me to define a wave number. Here I am taking this complete one cycle or complete one wave is known as wavelength lambda. Right? And this can be also taken as taken as time period t. So what is time period t? If it completes this complete wave cycle, how much time it will take, that is known as time period t. Okay. Now here for and one more thing is already in the which one previous already explained about the phases difference also. This 0, 90, this 180, how it got already explained in that videos. You can watch that videos there. So this 180, this 270 and this is 360. Okay, right. So for lambda value, what is this? Lambda is in meters, this is in angles. So your lambda value is nothing but 360 means 2 pi. Okay, and same here, your time period t is again 2 pi in terms of angle. Right. So in meters, whatever the value which is in meters per second, this total value of one wave is nothing but 360 degrees. So your lambda is 2 pi, t is 2 pi. Right. Now I want which one, not for lambda, I want, because this is a which one standard, no, for lambda it is 360 degrees. Suppose if I want here means that is lambda by 4, here lambda by 2 and so on. You can, because whenever it is lambda, what is this value you can take on the which one wave, you can take this value of wave, it may be lambda by 2 or lambda by 4. So you can write down that which one phase, which one angle there, right? But if you take any 2 points here, so this is not standard here. Suppose I am taking these 2 points. So suppose this is delta x. For delta x means path difference is there. So this is the path. So a path difference is there between these 2 points. Suppose this point is Pu, this point is Q. So between these 2 points, right? Between these 2 points, a path difference is there, right? So for that one, for total is lambda. For delta x, suppose you take this delta x, what is this phase, which one phase difference? That is phi. What is that value? Here, when you take this time period, if you take one more wave like this, So already explained in the previous videos, but I am summarizing here. If you take one more wave like this, here a time difference is there between these two. If you take that is delta t, right? So for a time period t, it is 2 pi. For this delta t, how much? Right? Delta t, what is the phase difference? That these two equations already I derived. Now again I am writing here to define this wave number. To define the wave number, we require these formulas here, right? So phi into lambda equal to 2 pi into delta x. 2 pi into delta x. So what is this phase difference phi? 2 pi by lambda into delta x. Right? What is the here? If you write same thing, what is phase difference here? 2 pi by t. This one 2 pi by t into delta t. So these are the which one formulas already in the previous I already explained, and again I wrote here, again I explained here. So these are known as standard phase difference formulas. Phase difference with respect to path difference, phase difference with respect to time difference. Now here I am defining a wave number here, right? So what is this wave number here? Wave number is nothing but if you take this 2 pi by lambda, right? So 2 pi by lambda here, okay, I am taking this as phi equal to, I am writing some constant k here, k into delta x, right? So this k is known as wave number. K is known as wave number. Okay. So what is wave number now? 2 pi by lambda. So your wave number notation in physics is k. What is the k value? 2 pi by lambda. Okay. Now you can show here in the figure like this. This is t here, right? So this is the curve here, right? This lambda is nothing but this value already explained is known as lambda, and this is a angle 2 pi. So what is wave number? Wave number k is ratio of this one to this one, 2 pi by lambda. Ratio of 2 pi to the lambda is known as wave number, right? So what is this definition? You can write down it, the ratio of phase difference. This phase difference to this one is path. No, this is lambda is path difference. So what is definition? It is ratio of phase difference to path difference. Okay. So this is the definition of wave number, right? Right. Now you can remember this one. This is a very important formula here. Phi equal to 2 pi by lambda into delta x. So this is known as wave number k. What k is known as wave number, right? Okay, thank you.